Good evening and Merry 2023. So, uh, there's a situation afoot with older computers where if you need to get something onto an older computer, um, your options for doing so are um, changing and sometimes diminishing. And of course, the normal way to do it is to be a YouTuber and have like two storage units full of random old computer parts. But if you're just getting into it, or if you're not a collector and you just happen to have some old machines that you'd like to um, get running, uh, or you just don't feel like having mountains of old parts, there are ways that you can communicate with newer equipment uh, without having to resort to finding a USB floppy drive or finding a compact flash card adapter or something like that. This machine, just through the grace of sweet baby Jesus, as somebody made a compact flash adapter for this laptop, um, and I have it, but I don't have a compact flash reader other than this one. So if I want to get stuff across to it, I could use a disc, a 3.5 inch disc, except I have no modern machines that have a 3.5 inch drive. I don't have a USB floppy drive, and I don't care to get one. I don't want to dig with that. I'm not that deep into this hobby. But I have this machine, and I have a boot disk for it, and I have a scratch disk for it, and I have a USB to serial adapter with a gender changer, and a modern laptop. And that's all I need to get these two things talking to each other, so I can transfer stuff from a current machine to this old machine. And I'm going to show you how to do it with just a boot disk. So yeah, I'm going to unfold this, line everything up. So this does not have a backlit screen, so it's going to be a little bit hard for you to see, but hopefully you can get the broad strokes. So this is just a laptop. It was, I don't know, 90 bucks. It's just a old, like, not even old, it's a school type netbook thing. So we've got our boot disk with the original MS-DOS end user license agreement. So I'm just going to pop this in here, start it up. As this boots it, it'll mention that it's got that CF card adapter in it, but I don't actually have a card in it. We're just going off of the floppies. So the concept is you get a modern machine, you put a copy of Kermit on it, which is the Unix version of Kermit, which is a file transfer program. This boot disk has a bunch of stuff on it from the previous people who used it, and all I'm going to use the boot disk for to save it, because it is an original disk, is I'm going to format a new disk. And while that's going on, so I've got a copy of Kermit installed, and what I'm going to do is hook this up. Now this is using Debian. It doesn't really matter what you use. I just use Debian because that's what I got. So this is just going to go straight into the serial port on this machine. And then over here, we're going to have a new device called TTY USB 0. That's teletype USB 0. And what we're going to do is, as root, we're going to make sure that we can read and write to that port as a user. You can go through a whole rigmarole and deal with permissions if you want, but we're just doing it this way. Then over here, we're going to start Kermit. And so Kermit's a command line driven thing, and you just say set port dev TTY USB 0. So that way it knows it's talking down this wire. And what we're going to do is we're going to set the speed to 300 bits per second. That's a nice, easy, slow speed. Because what we're going to do is we're going to copy stuff straight over the wire in text mode using DOS's built-in commands. But there's not going to be any flow control, so we're just going to do it as slow as we can. Okay, so this is formatted. Now I'm going to say sys b:. That's going to transfer the system files over to the second drive. And there's a couple of options. The option we're going to do is we're going to use just the basic system with mode.com. That's a thing that lets you set the serial port parameters. And we also have to copy, because this is DOS 3.2, it doesn't do it by itself. We have to copy the command.com to the new drive. And we're also going to copy mode.com. I don't think there's anything else we need. I think that's going to do it. Oh, one other thing that I am going to do is copy vdisk.sys. That is a RAM disk. This machine has 640K of memory on it. And just so we don't have to play around with the drives too terribly much, we're going to set up a RAM disk. And the way to do that without having an editor or anything, you can say copy from the console to config.sys. And we're going to say device equals vdisk.sys. We're going to go with 320K. Control Z. And there we go. Now when we switch these out and reboot off of this, we're going to have a 300K RAM disk, probably C: or D:. Yep, so virtual disk C, disk size 320K. So we can go straight over to the RAM disk. We'll say a:/mode com1 300 N81. That's 300 bits per second, no stop bits, 8 data bits, or no parity, 8 data bits, 1 stop bit. And what I'm going to copy over is two different programs. I'm going to copy over a thing called, well, I'm going to copy over a thing called a boo file, which is a boot file. It's an ASCII encoded file that can be converted with the second program to turn it into an executable. And that executable is going to be a tiny copy of Kermit, which we can use to transfer a large copy of Kermit over. So I just realized I haven't copied that over to this machine, so I'm going to get that, and we'll go from there. Okay, so the file I forgot to get was this thing. It's msbpcg.com, and it's a specially arranged command file that actually contains only printable characters. So it's safe to send over a text mode connection, which is what we have right here. There's also, if you don't have a copy of mode, there's another program called tcon, which is something that you can actually type in at the console, just like we did to set up the config.sys. And you can type that in, and that sets the serial port to 300 bits per second, and just reads from it and then writes to the standard output, so you can send it to a file, and you can get stuff over that way if you don't have a copy of mode. We have a copy of mode, so we're not going to mess with it. But what we are going to do is we're going to say copy com1 to, we're going to send over this MSB PCG thing, but I'm just going to call it unboo because that's what it does. So this is just going to sit here and wait for us. And over here what we're going to do is we're going to tell it to send an end of file when it's done, which is going to be 26, character 26, that's Control Z. And then what we're going to do is we're going to transmit no wait, so it's not going to wait for a response from this thing, it's just going to blast it over. And we're going to say transparent, which means it's not going to change anything about this program, it's just going to send it straight over. And we're going to say msbpcg.com, and this is 550 bytes, so it takes just a little bit for it to go over because we're sending it as slow as we can. This is returned, and then this should return in a couple of moments here, hopefully. That's your first test. Okay, so it says one file copied. So that's our first test. We know that's made it. Now to see if it actually worked, we're going to just run it. And that appears not to have worked. So let's see what we've got here. Okay, it looks like there's a bunch of junk at the beginning of this, so I'm just going to try sending that one more time. You may find, because we're using as limited, these are primitive hand tools over here, so you may find that you have to screw around with it some before it actually will take. That looks closer. We definitely got a different output this time, so let's see if that works. Nope. So I'm going to restart this again. Double check our parameters. Those parameters are correct. And if we take a look at over here, this isn't going to tell us, but that's okay. So I'm going to restart this. We're going to kind of try it again from the top and see if we can't get this to take. Okay, this actually just took a couple more tries. So I did the same thing over here, copy com1 to unboo.com. Over here, no, this may not have made any difference. It may have just been the luck of the draw as far as the transfer went. But what I did instead of no weight transparent is I did no weight binary and sent over that file. Then at the end of it, I typed C for connect, which lets you type directly to this machine. And I just sent a control Z over here, which is what tells this machine that it's at the end of the file. Then, to break out of that, you just say control backslash and C again, which it shows you right here, and that'll drop you back to the C Kermit prompt. So then I tried running unboo, and there it is. It started up, it didn't crash, it gave us a usage listing. So the next thing we're going to do is the same deal, because this program is going to turn a text file into a binary, and the text file we want to send is this tinyk.boo. And this is not mine, none of this is mine, and I would have to double check to see what the original name of this thing was, but this is a tiny Kermit implementation. It runs at a fixed speed, and it is what you can use to bootstrap the rest of the machine. So, same deal here. We're going to, I'm actually going to send it the same way, no weight binary, tiny k.boo. And the same thing over here, copy com1 tiny k.boo. And this is obviously going to take a little bit longer to send than the original one because it's 1300 bytes instead of 550. This is just the bootstrap part. So once we get a copy of Kermit over here, then things become much easier. What makes this part harder is that you're telling two computers that really don't want to talk to each other how to do it. Also, since it just did this, when it finishes transmitting here, when it drops you back to a prompt, it may still have characters in the buffer that it's sending. So in this case, because we sent a binary and because we didn't tell it what the end of file character was, we're going to hit connect again. We're going to send a control Z. And then it happened to have finished, so it says one file copied. What we're going to try now is see if that actually worked. So we're going to say unboo tk.boo. Now, it can go one of three ways. You either get what you were after, you get an error, or you get something that it says is okay but is not okay. But in this case, we have tinyk.com, which is 1190 bytes on here. The tk.boo is 1352, so a few bytes more than what came in over here, but that may or may not have any bearing on anything. I am going to copy all of this over to the disk just in case we have to do this again. So we'll copy all of this to the A drive. But we're also going to run tinyk, and if tinyk works, then what it'll tell us is just waiting. And luck has struck us. We've got a waiting prompt right here. And so what we'll do over here is we'll tell this machine that we want the speed to be 9600 bits per second. And what we're going to do is just send MSK 316, which is our full-sized Kermit implementation. And this is coming right along. So this is sending very short packets. This is a very inefficient way to transfer stuff, but this has full error correction. You can see the error count is bouncing up here a little bit because there's still no flow control. So every time this thing stops to write to disk, even though it's writing to the RAM disk, it's going to be slow enough that it'll cause an error. But you can see our progress bar is cooking along right here, and we'll have our full copy of Kermit over in just a few minutes. So I'm not going to make you wait and watch for that. But once this is done, we'll just copy it all to the, we'll copy this program over to the floppy disk. You can get by with not using a RAM disk at all, but the advantage of using the RAM disk is this would be running the floppy drive, which who knows how long it's going to last, the entire time it's transferring data, because it's just going to be writing tiny bits of it at a time. In this way, we're transferring everything into memory, and then we'll just copy it to a disk when it's done. So I'll bring you back when that's finished. Several minutes later, this is almost done. You can see where our error count has jumped up to about 100. But that transfer completed. This thing says OK. It says it's done. And if we look, we now have msk316.exe. It's 256,322 bytes, just like it was over here. So we're going to just copy this to the floppy disk, because right now it's only in memory. And because this is a large program, and because we made a large RAM disk to hold it, we are going to have to erase that config sys so that when this machine reboots, we'll have enough memory to actually run the program. But for right now, we're just going to copy this over. And from here, like I said, things get much easier. We'll be able to start the full copy of MS Kermit over here. We can use larger packet sizes. We can use flow control. We can use a bunch of stuff that will make this run a lot better. And since we've gotten this far, I also took the liberty of putting a game over here. So we're going to I'm going to show you how to copy that stuff. But for right now, I'm going to delete that config sys. And we're going to restart. And I think I got to get the camera some juice, so I'm going to bring you back. Okay, so now we've rebooted. And you can see we don't have a RAM disk anymore, but we should have our MSK316, that's MS Kermit 3.16. And because we can enable flow control, we can move this one along much faster, and we can also use larger packets. So we can move things right along. So here we are, 3.16 beta, May 1999. So what we can do here is we can set our speed. We'll set it to 19,200. You can also, if you don't feel like typing the whole word, it just needs enough characters for it to be unambiguous, and it'll tell you if it is or isn't. So set speed 19,200. We'll set flow control to RTS CTS, and we'll do the same over here if it'll let us. And what we're going to do over here also is we're going to set our receive packet length to something longer. So the normal is like 100 characters or so, 90 characters, something like that. And so we're going to set it to 9,000 characters, which means it's not going to spend so much time talking to itself. It will spend more time actually transferring files. So set receive packet length 9024. Over here we're going to set the send packet length 9024. And one thing we can do right now is just say connect on this machine and connect on this machine and see if they talk. Hello? So this is sending us garbage. That's because this is still set to 9600. So I'm going to break out of this, set the speed to 19.2, and then reconnect and say, hello there. And it says hello. And if I say hello there, then it shows up over here. So we know we're good. Getting out of here is the same control close bracket and then C to close the connection. Though you can also just leave it connected if you feel like. As a matter of fact, I'll do that now because this will automatically start receiving if it's in the connect mode. So we'll break out over here, and I'm going to change to my my Mars Monuments of Mars game, and this can send and receive multiple files. So I'm just going to say send star, and that should see it's copying stuff over right now with pretty decent speed. It's you can see the packet length changes. It's not going to be necessarily what you say. If it's having trouble with errors, like this is having some trouble with timeouts and stuff because this thing is writing to the drive, then it'll just start sending smaller and smaller packets until more stuff gets through, and then it will gradually expand. So it's really a very advanced program. Like it's very smart about getting stuff across. There was a reason that it was so popular in the 80s. It had a reputation for being slow. It's not slow anymore, and it's coming right along. The battery's kind of low on this thing. So you can see we've got a fair number of errors over here, but that's just telling you how many times it had to retry something. This hasn't actually had to retry anything, so this is just a timeout error, I think. And of course, if we were saving to a compact flash card or something, it would be a lot faster, because right now we're just waiting mostly for the disk drive. So transferring files is the main thing you can do with Kermit, but it happens that MS Kermit is also a pretty good terminal program, and so you can actually make one of these machines a lot more useful just by right of it being a terminal program. And the beeps mean we're done. So it's dropped back to a prompt here, it's dropped back to the connect mode here. We're just going to say close the connection, quit. And now we have Monuments of Mars over here. Hooray! Inverse video Apogee shareware game. So that's enough of that. I'm going to close this out, and I'm going to show you how you can do more useful stuff, potentially, depending on what you're after. How you can use this as a decent quality video terminal. So I'm going to put this away, because this is no longer required. Instead, we're going to use this feller, which is something that I made a while back. It's a Raspberry Pi Zero at W that also happens to have a USB power bank, or the guts of a USB power bank. And this is an active level converter thing, so this is a serial port that's compatible with this guy. So I'm going to get that set up and bring you right back. Okay, so we're back here. No more big laptop. We've just got this guy, which is, like I said, it's a Raspberry Pi Zero W with the serial line soldered to that RS-232 connection. So we've just got Kermit running on here, and what we're going to do is we're going to set the speed to 9600. We're going to set flow to RTS, and we're going to connect. And in this case, we've got our login right here. So I'm going to log in. Oh, that's interesting. Okay, so I just set the terminal mode to ANSI. On here, I've been using this to transfer files over to here for a while. So I have, for example, the image of this DOS disk, and I have a couple different versions of Kermit. I've got mouse drivers. I've got various things that I would send over to this machine. But I don't have to use it for that. But I will show you. Just for S&Gs, I'm going to show you, we can transfer this Wizard's Castle thing over here, and even though we're directly connected and we're using the serial thing as our terminal, we can still run Kermit through here, and Kermit will still work the same way as it did when we were connected through, indirectly without a login. So we'll just type Kermit again, and we've got, it's all the same stuff. We don't have to set the bit rate or the flow control, because that's already been done by the system. So instead, all we have to do is we'll say send wizard.base, and just like before, it's copying it over. Now, because I didn't set the packet size, it's sending the smaller packets, the 90 character packets. Not that that's a big deal, because this is like I don't know, 30K. Obviously you don't get to see the C Kermit side, because it's busy talking to this one. But the advantage is, this is now for all intents and purposes a serial terminal for this machine. So even though this was built in 1987, this thing has Wi-Fi and half a gig of memory. So you can still do web browsing and stuff. You can still get files from the internet. You can get files from other computers. It makes it really easy to get stuff onto and off of this machine, as well as just being able to use this for other purposes. So, this is just a regular Linux login. So I can do my Python stuff. I can use a web browser. I forget which one I have on here. And you can do all that stuff. Except for this, right now, because it doesn't seem to want to. How about links? You can also use screens, so you can have multiple windows open, just like you can with a regular secure shell connection. This thing may be busy right now. Let's see what it's doing. I guess it's not. But anyway, so with something like this, where you're using the serial output of this as a console, you get all the advantages of having a modern system, and you can talk to it with the terminal software on here. You can also, because Kermit has Tech 4010 emulation. I'm not sure if I have NewPlot on here, but yeah, I do. So if I set term tech, let's see what we got here. So we're going to say tech 40xx. So set term tech 40xx. And then back here, let's see if we've got tech emulation turned on. That should be automatic. Let's see if it works. Oh wait, set tech enable. Set term tech enable. So now, if we say like let's plot x to y to, then you can actually do some graphics mode stuff. So the plotting is being done over here, and the output is being done here. So you're not limited to just text mode. You can do certain amounts of graphic stuff too. So it's all pretty badass. And I think that's where I'm going to end it. You can see Kermit, the MS Kermit is a really powerful program. You can do lots of stuff with it. You can breathe new life into these old machines by being able to use these as a terminal. Something like this is a Turbo XT. It's 7 megahertz and change. It is plenty fast enough for terminal duty, and it's hard to photograph, but it's actually got a pretty good quality screen if you're in decent light, and it's got an excellent Alps keyboard. So yeah, I'm going to shut this one down. And get out of Kermit, and that's that. Have a good night.